and elementary operations. Now the first thing that I'm going to do is I'm going to set up an augmented matrix. And x, 1x, 2y, constant, 1x, 1y, constant. Then I'll go in and I will put in my main diagonal, and I know that everything below it needs to be 0. That means I'm going to use this 1 to get rid of that 1. So I'm going to create a new matrix, and the new matrix is going to be created by taking -1 times row 1, adding it to row 2 to give me a new row 2. So 1, 2, 5, that remains the same. I need a 0 in this position, and by multiplying by -1 and adding, I'll get a 0. So -1 times row 1 is going to be -1, -2, -5. Added to row 2, which is 1, 1, 3, gives me a new row 2 in my matrix, which is 0, -1, -2. Now I go down the main diagonal. Main diagonal does not have to be 1s, not when you're putting it in upper triangular form. And I've got 0s in the proper position, so what do I know? I know that x plus 2y equals 5, minus y equals -2, so that y is 2. So I've got y. X plus 2y equals 5, so that says that x plus 2 times 2 equals 5. X plus 4 equals 5, or x is 1. So x equals 1, y equals 2.
How did you, on the x plus 2y equals 5, how did you get -y?
From this guy right here?
Oh, okay.
Yeah.
I guess I messed up.
So what's the thing that we don't like about this problem? Fractions. That's clear. So one of the things that I would do before I even set up the matrix, multiply both sides by 3. What will that do? Get rid of the fraction. So I would have 12x plus 6y equals 8. This guy's now gone, and then that's now my system. So my augmented matrix is 3, 3, 3, 12, 6, 8. Now I can do one of two things. I notice that 3 is a multiple of 12, is it not?
Right.
So if I multiply by -4 and add, the 12 will get killed, because if I think about it, this being the main diagonal, I need a 0 in that position, and by multiplying by -4 and adding, will that not put a 0 here?
Correct.
Yeah. If I wasn't that lucky, this is something that I could do. I noticed that if I put a 1 in this position, no matter what number I have down here, I could kill. Now, what I could do is to create a new matrix, and that new matrix, what I would do is I would take 1/3 times row 1 to give me a new row 1. That puts a 1 in this position, a 1 in this position, a 1 in that position, and no matter what number is down there, I could kill it. So because 12 is a multiple of 3, I don't have to do that. But if I had a 7 here, 7 and 3 would have nothing in common, then what would I do? Well, I'd put a 1 in this position by multiplying the whole row by 1/3. Now, regardless of what this number is, I could then eliminate it because that's a 1. And this is an elementary row operation. Multiply any row by a constant, you still maintain the same solution set. Not the same matrix, but the same solution set. So which one do you want me to work? First, second?
First.
First, okay. Well, I need to create a new matrix. And the first row remains fixed because it's the row I'm operating with. I need a 0 where that 12 is. So in order to do that, in my new matrix, I'm going to take -4 times row 1, add it to row 2 to give me a new row 2. So -4 times row 1 is -12, -12, -12. Add it to row 2, which is 12, 6, 8. Gives me a new row 2, which is 0, -6, -4. Now, if I go down the main diagonal, I've got zeros where I need them. So now I can wind it out. 3x plus 3y equals 3. -6y equals -4. I can solve for y. So y is 2/3. And yes, you can have fractions for answers, unfortunately. Well, if y is 2/3, I know that 3 times 2/3, 3 times x plus 3 times 2/3 equals 3. The 3's will reduce out. That's very nice. 3x equals, or 3x plus 2 equals 3. 3x equals -2, or x is -2/3. So we get y is positive 2/3, x is -2/3.
That's funny.
Hopefully.
How is 3x -2?
Oh, it's not. 3x is -1, isn't it?
1/3.
So it should be -1/3. I want,
Not funny anymore.
not funny anymore now. That's positive 1/3. I wondered because when I was going up here, I did a mental check, and I thought, I don't think that's going to equal 3. So there we go. This is what's going to get you. It is not going to be necessarily the process, it's working with the damn numbers. That's what's going to get you. It's going to be the arithmetic. Thank you.